I like to think that here at Snazzy Labs, we have a pretty awesome networking setup. We have 10 gigabit Ethernet going to all of our computers. And thanks to our 336 terabyte Margaret server, not only can we share files across the network, but we actually edit all of our videos live off of the network. Check that video out if you haven't seen it. More recently, we upgraded to an LTO tape solution so that we could do off-site backups. But there's still one thing about our networking that has really sucked, and that's our internet connection. We've been paying for an Xfinity Business crappy 50 megabits per second down, 20 megabits per second up plan for the last several years. Well, today we're upgrading to fiber, and it's going to be awesome. To start our fiber adventures, we have to start outside. So let's go. This has nothing to do with fiber internet. I just wanted to open it for fun. What we got to talk about now is... What we got to talk about is known as the last mile problem. Think of your internet service provider as a tree. Now, internet service providers don't typically give life, they suck it, but we're going to use it as a metaphor. A tree has a trunk, a bunch of smaller branches, and then a bunch of tiny little twigs. You, the end user, the customer, are the twigs, and that distance from that little branch to the end of the twig is what is known as the last mile. This is the most numerous part of running an internet service, and it's also the most expensive. Furthermore, it uses the most antiquated technology. Most people have coaxial cable slams in their neighborhood or cable drops, and then they are running into their house using old coaxial cable or twisted pairs, old technology. Now, fiber cable, you might think, fixes all of that. Now, that's not necessarily true because here in the United States, fiber is advertised a little bit differently than fiber elsewhere in the world. Let me show you why. You see, your ISP or telecom is most definitely using fiber, even if you're not aware of it. An example is, you know those old school landline telephones? Ahoy hoy! Those now in modern day typically have fiber backends. So the question is not, is my ISP using fiber? Because they are. But where does it change from fiber to copper before it hits me, the end customer? And that's what's known as FTTX, or fiber to the variable. Now, that variable might be that the fiber terminates at the node, or that it comes all the way to the curb, or that it goes all the way to your building, or that it goes all the way to your individual unit or home. This is a box right here, and I'm not going to pretend to be a science man and know what's inside here. I'm no engineer. I'm certainly no network admin, but what I do know is that this box was here before. My ISP had placed that, and there is a fiber conduit going into that box. Then, from this box, they can go to buildings in the area. Luckily, I was right next to this box, and so they dug up the ground here. You can see the grass looks a little sad. It'll grow back. Don't worry, landlord. And it comes out of this little tube right here. Now this tube you'll see has one cable, and that's because it goes to me, Snazzy Labs. I so far am the only customer of this fiber company in this specific building or unit. Now, you might be thinking, oh yeah, sure, there's a fiber to every individual person, but that's not really the case at all. Even in fiber to the home applications where every single customer would get their own cable, that doesn't mean that the cables all have a direct line of sight from your building to the ISP. Let me explain why. Okay, we're back inside and it is so hot, it might even be hotter than outside. We're in a brick building, but that's okay because we've got fiber to the home. You remember from earlier, that doesn't mean we have twisted pair or coaxial cable. We have right here an optical fiber that plugs right into here. And there you go, those little green lights mean that we have internet. Now, in fiber to the home deployments, there are really two networks and methods that can be utilized. There is passive optical networks and active optical networks. Now, PONs, passive ones, are far more common because they're less expensive. It takes a single optical fiber and then splits it up to 128 times, which can go to 128 customers. Now, what this means is that it's often more cost effective, and this is why you see it in more fiber deployments, but the downsides should be relatively obvious. You're now sharing that optical fiber with up to 128 other people. Now, generally it's okay because, well, fiber is pretty cool. You can operate at different wavelengths and do packet switching and all this stuff. But the more preferred method and the more expensive method, and obviously, as a consequence, the less common method, is an active optical network. Active optical networks are different in the sense that it uses active powered equipment to get from here back to the main office or my ISP. So this line coming in, this little cable right here, doesn't share with anyone else. It's just for Snazzy Labs. And it can carry full duplex 1,000 megabits per second in either direction, which is insane. Now, this is not only an active optical network, but it is an active E, or active Ethernet network. If you think about Ethernet, it's pretty obvious. You have a main router, which you have inside your home, and that routes traffic on your local area network. Active Ethernet fiber networks are not all that dissimilar. The difference is, rather than going to your computer or your printer, it goes from building to building to building back to your ISP. This box, the Juniper EX2300C, merely takes that incoming optical Ethernet signal and then converts it to something that is more usable, aka RJ45 copper cabling. But we're actually going to go optical all the way over to our server rack there, and let me explain why and how we're going to do it. In most deployments, like your home or your office, you'll see one of these. They call these wireless routers, but they are actually four things. They're a modem, which receives the incoming cable over coaxial and then converts it into something actually usable. It is a router, which in the name routes local and wide traffic so that you can access the internet and talk to devices on the same network. It is a network switch, which allows you to plug all of your devices in, and then it is also an access point or a Wi-Fi hotspot. Because these are often cheap or free included with your contract, they typically suck. So you want to get something that's much better. We have decided to opt for a UniFi Dream Machine Pro. This thing is super cool, and I am excited to use it. Luckily, the UniFi warehouse is located here in town, so I bought this on Friday and got it on Saturday. And I paid for UPS ground shipping, so that's nice. Anyway, this box is a cool one for a couple of reasons. Number one, UniFi has incredible system management and apps, so it's very easy to set up and monitor. It's also nice because it does, well, a couple things. It's not a modem, so you're still going to need a modem. And if you have a modem and you want to use one of these, you can put your crappy Comcast modem into what's called bridge mode. And that basically just allows you to pass the internet over gigabit RJ45 copper to a device that acts as the router and the switch and the access point and everything else. This also doesn't have Wi-Fi built in, so you're going to need to buy separate access points, but you're generally going to want to do that anyway because built-in ones, even router access point combos, are not very good. And then this has a network switch built in. So they call this a managed switch, but really what it is it's a router and security gateway that has firewall settings. We'll talk about all the cool security features of this device in a minute, but basically what happens is you plug it into your wall or you put it in a rack. You have a little hard drive here, which allows you to use UniFi Protect. We'll talk about that probably at a later date because I actually think I'm going to do something about it, but basically it allows you to run webcams and record them in a PVR in this box. So this does a lot more than just act as a router. And then you have your network switch here. But again, I want to mention something pretty crucial. The system we're paying for accounts for symmetrical gigabit fiber. So 1,000 megabits per second down and 1,000 megabits per second up. And most RJ45 copper cabling, single gig cable, Cat5e, that's limited to about practically 900-ish, 920-ish megabits per second. So we're paying for speed that we can't actually utilize. Because we have a 10 gig network, I want to keep it everywhere as long as we're going on, like if we have to go copper, go 10 gig the whole way so that we can get that full 1,000 megabits per second. Let's try it. Okay, so as we discussed earlier, fiber comes in from the street into this box. I then decided to wire another 10 gig connection from this box over to the Ubiquiti Dream Machine Pro, which rather than keep over here, I thought it best to keep in, well, our server rack with all of our equipment. And so that's what I spent the weekend doing, running fiber cable across the top of the warehouse and right into here. You can see the incoming fiber line. It goes into the Dream Machine Pro, and then we actually have another cable coming right back out. That's a 10 gig SFP cable as well. It's called a direct attach cable. Unlike this one, it's not actually fiber optic, it's just copper, but it's a short cable that goes into here. This is our Arista 7050T switch. Now this is an old piece of enterprise gear. It's from about 2013, but because it's old enterprise gear, you can get it for cheap, about 400 bucks, and the specs are incredible. This thing has 48 RJ45 10 gigabit Ethernet connections, and then 4 40 gigabit quad SFP connections. So we're going SFP to quad SFP, so 10 gig connection basically, and then 10 gig out into every single one of our computers, which I have wired up through this patch panel here. This allows us to have just a couple nice, neat little cables, and it looks and feels fantastic. Now, I did a bunch of general maintenance too. We keep this server in a shop, and so I decided to pull all of the equipment out, move this server rack back a couple inches so we could close the door successfully, and then clean all of the equipment while it was in there. Now, you might be wondering, Quinn, you're wiring that via fiber, but isn't fiber fragile? And this is something that a lot of people have said. Yeah, I wired fiber cable just across the top of my roof, not too carefully. I want to answer the question, how fragile is this stuff? So let's plug one end into here, our Ubiquiti Dream Machine Pro, the other end into our switch. That is the switch we talked about earlier where our fiber connection comes in, and we will head to the computer and see what it takes to break an optical fiber cable. Okay, we are going to increasingly bend this cable to see how severe of a bend we can get before the internet connection drops out. This is the only connection that I have to my network, and this is the only connection that we have to the internet. So as soon as the fiber cable breaks, so too does my internet. So as you can see, it works fine right now. Let's bend it to about right there, which I had a bend way less severe than this, and people were like, it's not gonna work, you're gonna break it. It's working fine. I can load web pages just great. Okay, let's go with a slightly tighter bend. This one is pretty dang stressful. You can see visual stressing on the top of the cable right here. We're stretching the jacket. And everything is, it does look like it's slowed down, but it's not broken. What happens if we straighten the cable back out? Wow. Is that right? Does it stop working when we have a bend in it? Okay, so here we go. We've bent it pretty severely. That's bananas. So it works as long as the cable is flat. But as soon as we put a really severe bend in the cable, it stops working. Let's try that one more time. And watch. You ready? We straighten the cable out. That is nuts. Okay, so cable seems to be pretty durable. It doesn't seem like it breaks. It just cuts the connection until you straighten it back out. What about that? That's definitely not going to work. No way. Yeah, completely dead. No connection back to The Verge's website. But if we undo that bend, does it restore itself to its full glory? It does. That is crazy sauce. Okay, so we are connected on my Mac Pro. I have a green status light, which means the internet is working. I mean, you kind of saw that earlier with the fiber test, but okay, let's see how quick this actually is in real world practice. We're gonna open Safari here and go to, I don't know, The Verge, just a website. Oh, wow, that loads almost instantly. That is crazy, crazy, crazy quick. Okay, let's try something a little more difficult like youtube.com. Okay, that was okay. It wasn't crazy fast. Let's load a video up though. Oh, how about the 8K Marquez video that he did a couple years ago or whatever? Oh, 8K. Oh, this one from 5 months ago is 8K. Okay, let's watch this. We are going to, oh, we're in Safari. Whoops. So we're going to need to open Edge because Safari doesn't support higher than 1440p because of the VP9 codec. Okay, wow, look at that. It autoed to 8K. When have you ever seen a video auto to 8K? That is bananas. Okay, sure. Let's press play. And that's kind of cheating because we've got a buffer already here. You can see that there's a buffer here along the bottom, but it's basically loading it real time. If we jump ahead, look at that. That is just blazing through. That's 8K video. And it looks like it's buffered more than my computer can keep inside of its volatile memory. I mean, look at that. It's just instant. You click anywhere in the video, and we're advancing, so it's not like this has been rendered yet. Oh, this one's a little slower. But still, you can see Marquez's pores. That's nuts. Okay, but let's talk about something a little more practical for my use, uploading videos, because a lot of people can have really fast download speeds. We have, for example, at my house, cable is about 650 megabits per second down, but only about 15 megabits per second up. We're used to about 25 on a good day upload speeds, which means our videos, which are usually, I don't know, 6, 7 gigs, take about 2 to 4 hours to upload. It's pretty slow. Let's try this one. Let's get a, here's a 4 gig file. So this is, let's do a little smaller one. Let's do 1.24 gigs right here. Or how about this one, 2.57, that's good. We'll drop that in. And, oh my gosh, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That is insanely, 38 seconds left to upload a 3 gig video. So a 6 gig video, which is what we normally have, will take what, 45 seconds, maybe a minute? That is nuts. I don't even know if we'll be able to like enter all of the metadata before the videos are done uploading. That's insane. Wow. Okay, but we got to do the kind of like the creme de la creme of like flexing on your network speeds, and that's a speed test. So we're going to go to speedtest.net by Ookla, and we are going to press go. Okay, it's probably getting our ping time, I would guess. I'm expecting a couple milliseconds because my internet at home was about 10 or 15, which was pretty good. See, that can't be right. 0 milliseconds? Oh my gosh. Look at that download speed. 936 megabits per second, 937. That's insane. But this is where things get nuts, is the upload speed. Because again, we were used to kind of taking a couple minutes or a couple hours to upload our videos, and now 918, 917, 915. The test is done. That is awesome. That is freaking sweet. Now, I do think we can get a little faster. We're supposed to be able to get true 1000, 1000. Now, that might be some configuration issues on the Ubiquiti. I'll look into that and kind of see if I can fine tune that, but that's pretty dang good. Now let's address that 0 millisecond ping, because I kind of don't believe that. Because generally, you'll have like a 1 to 2 millisecond ping within your own home running from your computer to your router. Now granted, we are running 10 gig everywhere, and then our copper run, the only copper we're using is from here to our switch, which is not that long. It's mostly optical all the way through. Another thing people kind of misunderstand about ping is they think that it's just like some generic number that's like a universal ping. No, it's not. All ping is the latency between your device and whichever server you're trying to communicate with. Now in my case, speedtest.net has selected Utopia Fiber, which is my actual ISP. So it should be pretty quick because I'm talking to the people who give me internet. But let's send 10 little packets that we can ping and see what our latency time, oh my goodness, look at that. So it looks like speedtest.net rounds to the nearest number, which is true 0. Our slowest packet took 0.2 milliseconds, and our fastest packet took 0.151 with an average of 0.177 milliseconds. That's about 0.2 milliseconds to our ISP and back. What does this mean practically? Well, in theory, the faster you can get to your ISP, the faster you can get to the greater internet, so long as your ISP is good. And so in instances like online gaming, this should be a massive advantage, because like at my home, I'm used to a 15 to 20 millisecond ping just between my home and my own ISP. And then going from them to the game servers is another 10, 20, 30, 40, 50, sometimes more milliseconds. So let's try out a game and see how low we can get that ping. Okay, here we are playing Call of Duty Gunfight. Please try to ignore the insane graphical glitches that are present because of AMD and NVIDIA's, or AMD and Apple's terrible boot camp drivers. But basically what I want to show you here is that ping time is, well, let me put it this way. When you have fiber internet, you're only as good as the weakest link, which can oftentimes be the server that you're requesting information from. So my ping to this server is 50 milliseconds. I'm actually a lot higher than some of the other players, 36 and 40. And that's just because of Activision not having very good servers to have this game played from here in Salt Lake City. Now there are other games like CSGO, which do a much better job. Let's load one of those games up. I would say if I could play CSGO, but I can't. So I am going to use this website, which allows you to ping the CSGO servers, and I'm going to ping all of them. You can see pretty quickly that the Northern California would probably be the one I default to at about 30 milliseconds. And that's pretty quick. I can run these ping times again to get a second average, 30, 32. That's much better than the Call of Duty servers, but then someone like Mumbai, India would be almost a quarter of a second. Really unplayably bad. And that's really what it comes down to. Where are you located in the world relative to the servers that you're trying to reach? And how do the servers send you data? I think you'll find, as I have, that As soon as you have very, very fast internet connection, you'll notice that a lot of websites just aren't that fast. I downloaded the Catalina update for my Mac Pro, and it was only downloading at about 80 megabits per second. I think that's just because that's how quickly Apple sent the download, not that my internet connection wasn't fast enough, because it was. Other areas though, especially game downloads, Steam does an incredible job at pushing you almost full speed that your network connection can handle. I was downloading games at 90, 100 megabytes per second, which is bananas. Well, there you have it. It's rough living with fiber. Needless to say, I think this fiber internet is going to be an excellent addition to Snazzy Labs. It will make our lives easier, it will make our jobs more fun, and I mean, come on, who doesn't want fiber internet? Stay tuned because we do have a future episode of us actually visiting our ISP to do some facility tours. It's gonna be great. Thank you so much for watching. If you enjoyed this video, please give it a like. If you didn't, well, that other button seems to work okay too. Get subscribed for more awesome tech videos like this one, but most importantly, and as always, stay snazzy.